Hello everyone, welcome to the EasyPower Tuesday Refresher webinar series. Today we're going to be talking about the EasyPower SmartPDC feature. And for those of you that haven't joined us before, all those in attendance will receive a certificate of attendance via email for the time that they spent uh, attending this webinar. So appreciate your audience today. My name is Jim Chastain. I'm a solutions engineer with Bentley Systems. And the element we're talking about today is essentially unique to EasyPower. It's referred to as SmartPDC, although we talk in terms of auto coordination. This is going to be an introduction to the topic and the feature. So there's a lot more that can be extracted if you get in and really work with the tool. So we're going to describe what it is, where it can be used, which devices can be auto-coordinated, how to prevent changing device settings that you have made manually, and then in addition, some other benefits from the report. As we're in the habit of doing, we like to start with a poll question. And if you would please contribute your opinion based upon your experience, no liability for guesses. First question is, how often do your projects require protective device coordination? And so if you would please respond accordingly. And as I mentioned, there's no liability, no obligations, just strictly trying to get a perspective on the audience's exposure to this topic. So it looks like we're halfway to a quorum. Let's leave this open another 10 seconds. All right. Good. So here's how folks have weighed in on it. So it looks like it's a pretty popular requirement. Over 86% of the time, protective device coordination is required. All right. Then our second question is based on your experience, which is the most difficult to coordinate your exposure to the topic? So multi-case circuit breakers, fuses, ground protection, or some combination of the above. Again, this is a little bit discombobulated as far as the choices I give you, so I apologize for not being more specific. One of the things we don't cover much in some of the tutorials we do is ground protection. So I wanted to highlight that as one of the features. Okay, looks like we have a quorum. Here's how people have weighed in. Quite a bit more diversity here. Just as a heads up, multi-case circuit breakers, because they're defined to be operating in the first cycle of a fault, are difficult to coordinate with, and so you sometimes have to accept miscoordination or have to rely on manufacturer's test data to determine whether you have actual coordination on your system. But these others look like reasonable responses. I just want to mention, I don't very often talk about EasyPower as a sponsor, but one of the benefits of the EasyPower acquisition by Bentley is the need to have standardized packages that are available for our customers or clients to utilize. And a reduction in the choices of the features or the modules that are included in a particular license. And what I mean by that, originally, SmartPDC was a separate module that you could include or not include. But with today's grouping, anything except for the base package will include SmartPDC. And I bring this up because for those of you that have an EasyPower license, when you get to your renewal time for maintenance, you will be asked to make a decision about whether or not you want to participate or utilize the Bentley licensing system or to maintain your old EasyPower USB key. There are a lot of reasons to favor going with the Bentley solution, one of which is if you have anything but the base bundle, if you will, it will include the the SmartPDC option. So that's just a note to say that those of you that haven't upgraded your license to EasyPower 24.0 may benefit from exploring the potential that your license could actually be expanded by features that are now considered standard. And if you have a question along that lines, I'd encourage you to contact sales@easypower.com. So SmartPDC, which is often referred to as automatic coordination, allows the user to automatically coordinate breakers, fuses, relays, and multi-case circuit breakers based upon the loading downstream, which includes cable considerations, motors, linear loads, and other protective devices based upon rules that you've selected in the setup of the features. Now, just a caveat here, the tool cannot adjust fuses because they're not adjustable element, but it can verify that the fuse orientation or the fuse selected meets the rule requirements that are being given when the tool does the coordination task. So I'll try to show where that's the case and be able to amplify that when we get to it. Now, coordination, basically, and this is a good exercise to prove to yourself, for a particular bus, to be able to coordinate that bus itself, you need to coordinate against the largest downstream load. And the point I would want to make is once we've coordinated with the largest load, then the smaller loads on that bus will by default be coordinated with our setup upstream. Now, recommended settings are applied in a temporary database as the results of an auto coordination run. We may get some new settings for many of the devices, and so those are applied in a temporary database, and there's a report created called the auto coordination report that gives you the details on what was found originally, what the justification for any temporary change might be, and then also relay of any change that was not made and there's a violation of the rules that were set up. It's easier to see this whenever we get into it. I do want to emphasize that the function of auto coordination is not a substitute for engineering judgment. The intent is to make the engineer's time more valuable in the process, and many people would utilize SmartPDC as a first pass on what options are available for doing coordination, or as the last pass to make sure we haven't violated any rules that we're trying to follow once we've done the coordination manually. So there's different ways to apply it. It's not a replacement, though, for sound engineering judgment. So I want to emphasize that repeatedly. Now, the tool can be used to coordinate phase protective devices, ground protected devices, or both, and it will automatically consider the 87% shift in the transformer damage curves for primary protection devices. For those of you that don't know what that refers to, I would encourage you to consider attending the 4-part series on Introduction to Protective Device Coordination, which we do semi-annually. Now, you might say, well, once I've set up a particular device, a breaker or a relay setting, how can I prevent that from being changed if I want to auto-coordinate the rest of the system? And the answer for that is to go to the dialog box for that component and then lock the auto-coordination choice, which is right here on this dialog box for low voltage breakers. And so once that checkbox is made, this part will not be considered as far as an adjustable device, but it will be considered in the rule compliance that we've given it when we do the coordination setup. Now, I keep referring to the rules. What I'm talking about, when we go to auto coordinate PDC options, it brings us to this display, which are the backbone of the rules that the tool is set up to follow. And although I'm not going to go through all of the rules here, I would encourage you, if you have access to the tools, to utilize the help function when you're looking at the rules, because it will describe the different choices that you have. And I'll touch on that as we go through the demo here in a second. Now, probably as valuable as anything else, in addition to having automatic sizing or adjustments for the protective devices, is the ability to do a report that tells me what was done, the justification for doing it, and better still, what rules are being violated considering what we allowed the tool to do. And so you can produce an auto coordination phase report, which again will give you a specific protective device, what it's coordinated with, and the options for making the adjustment, and what's being considered as far as the rule violation. And these will throw a warning or a violation, which the engineer may or may not want to deal with. And then also we can produce an auto coordination ground report, which is the same thing for devices that have ground protection built into them, the old settings, the new settings, and the justification for the equipment that's being protected. Okay, so let's jump into the rules itself and see how this works. So I'm going to use an example that's built into the tool. It's called SmartPDC. For those of you that don't know, once you've loaded the EasyPower tools, if you go to open a one line from the start screen, it takes you to My Documents, EasyPower 24.0, one lines, and in that folder, there's a sample folder. These are all pre-drawn one lines that you can utilize and play with and sharpen your skills without worrying about changing any project that you're working on. So I'm going to look at the SmartPDC-1, and I right protect mine so I can't mess them up. And I want to point out a couple things while we're looking at the one line. First of all, if I want to, if in this case, this large motor is the largest one on this bus, largest load in this bus. So if I'm going to coordinate, I would coordinate against this motor load. With that said, even though these are large total horsepower motor control centers, they don't have any single load as large as this one. So that's why when I'm going to be coordinating for this bus, I do so with this as my primary load. But with that said, I can go into the setup for the motor control center and be able to coordinate devices that are internal to the motor control center itself. So let's say in this case, instead of having a main lug, we have a main fuse. We need to tell it what cable is coming in. And I'm going to set it up with a generic class L. And because we were set up with, I think, 800 amps, I'm going to pick this as a 800 amp fuse. Let's see. Let's see how I did. So if I save this, and look at my specification for the MCC. So yeah, so it's set up for 800 amps. And if I go to description, I want to pick out the largest load on the motor control center itself. In this case, it's this first motor we have listed. As I scroll over, I can see it's a 200 horsepower motor. And it's set up with the data button here for the motor itself. And so we set it up for 200 horsepower, then go into short circuit, calculate X over R. Now, once I've designated this load with a TCC, which is what the designation was from my description, now that it has a TCC, this will show up in my coordination analysis. So if I go to my protective device, again, I'd have to set up the breaker with the data block inside the description, and it's set up with 400 amp multi-case circuit breaker. We want to make sure we auto coordinate it. And we have it set up to trip on 1200 amps instantaneous. Okay, so now what am I doing all this? If I go back to if I go into coordination, pick out that motor control center, I can plot the TCC curves. And so here's my breaker, here's my motor load, here's the main fuse that I put in. Now I can invoke SmartPDC. As it does that, it coordinates for that large load downstream. Now in this case, I'm going to get a violation because the fuse is not coordinating with the breaker. If that's something I want to deal with, the tool will allow me to hover over the fuse. So it can't the feature SmartPDC cannot make an adjustment on the fuse. But I can manually say, well, if there's another one in the device library in the same family, will it perform better if I use a larger fuse? And so I may want to consider that as a solution. Again, I'm not replacing, the tool doesn't replace an engineering judgment. But once I've made this analysis, the tool creates the report for me. If I go to auto coordination phase report, here's the breaker, here's the fuse. It says it's not coordinating with the breaker, which we could tell by looking at it. And it looks like the breaker is doing a pretty good job for the motor. So the point I'm trying to make is, one, I can coordinate for a motor control center. Well, and then when I go in and look at this, let's take it back. Now that I've got these adjustments made, I'd probably save this display, this plot. I'm going to say yes. Let's say this is MCC2B. And now when I go back to database edit, that information, which is in a temporary format, when I go back to database edit, it says, do I want to save the changes? If I say yes, now the dial settings for this breaker have been locked in. Now, what if I want to not allow it to be changed if I do auto coordination on the whole system? I go back into my data dialog box for that breaker that's downstream or upstream of the motor, and I lock auto coordination. By doing that, I can now coordinate the whole system, and the adjustments won't affect the settings that I've locked in on this breaker. Okay, so what I'm trying to illustrate is we can coordinate a subsystem like a motor control center. We can coordinate the fuse. We can coordinate this breaker. Now that coordination didn't include this breaker up here. So I want to go back and adjust that for that particular load. But in terms of coordinating for this bus, I want to pick out the largest load, which is the motor. Left click and drag. Pick out the next 2 or 3 levels of voltage protection and current protection. Go to coordination. So now I'm coordinating for the switchgear bus 2A. I just undid it, so I'm going to redo it. And then I'm going to plot the TCC curves. Now, we're looking at, let's just choose phase only for now. Move our labels around so we can see what we're looking at. We can see the miscoordination as soon as we set this up. The motor load is the chair, the violet chair. The turquoise breaker is the first upstream breaker from the motor BL2C. The green line is the relay, which should be the last device that's going to clear. The magenta hockey stick or magenta golf club here, that's the trip center, the TCC plot for switchgear breaker 2A. And then my fuse is the ribbon, the red ribbon up at the top. Now, so this is the way I found it. What would the tool do for starters as far as doing auto coordination? So I'm going to invoke look at the motors. Look at the rules first. So under SmartPDC, look at the options. We want to start off with, under general, we want to start off with phase only because we don't have any ground protected devices in this one line. And we're going to stay with the default settings on the rest of the rules. So now I'm going to invoke SmartPDC. You'll see a rectangle here where it's going to do the calculations and going through all the data sheets. It's going to replot the TCC curves. And then also, if I fault this bus and look at the instant energy, it's going to recalculate the instant energy. So let's invoke SmartPDC. There's a rectangle, there's the replot, and there's the recalculation of instant energy. So our instant energy almost doubled. It went from 18 calories per square centimeter up to 32 calories. That's testimony to the fact that coordination very often contradicts mitigation. We're not talking safety, we're talking reliability of the system. You can see it's readjusted my turquoise breaker so that it falls within the thermal damage curve, which is a short stubby curve for the motor. It pulled down the magenta breaker. It pushed up the relay. Now it can't do anything with the fuse, but we need to look at the report to see if everything's following the rules that we've been given. We can see, well, just looking at this, so these two parallel lines, this is a transformer damage curves. The dotted line is 100% damage curve, and the solid line is a derated curve for a delta Y with primary protection, single line to ground. The thing that looks obvious, though, is that the fuse, FS6, doesn't do a good job of protecting the transformer damage curve. So let's see what the report has to say. Reports always show up under list of windows. The auto coordination phase report. Okay, BL2A. It tells us the old settings, what is coordinating with, the new recommended settings. It gives me a warning that says, hey, Jim, normally you've got this set to the maximum setting on BL2C. If you set a breaker with better granularity, you might have better luck with coordination. And then BL2C, it's coordinating with the motor. And here it's giving me a warning, say, Jim, normally we have an overload specified for a motor protection or a contactor. You don't have either one. You may want to look into that. We get down to the fuse and we see an error. And what this is telling us is that the transformer, as far as the fuse protection, isn't really being utilized because of the 175 amp plug fuse selection. So you may want to take a look at that because that's a violation of the rules that we gave the system to honor. And then when we get down to the relay, it tells what the relay is coordinating with, the old settings and the new settings. So I'd save a copy of this with my project. I'd save a copy of the TCC plot because we want to verify that we looked into it. And then, as I mentioned, the fuse can't be adjusted. The tool can't adjust the fuse, but if there's another value available in the device library on the same family and style, the tool will let us manually select it to see if it helps the situation. Well, the backstory on this is that the original design was made with a 125 amp fuse, but during an off shift, some electrician replaced this fuse, or the 125 amp fuse, with what he had available in the truck just to keep the plant up and running, and then didn't realize that he was putting the reliability of the transformer in jeopardy. So if I look at if I left click and drag on the fuse, the tool says, yeah, there's 125 amp available in the device library that would improve the protection of the transformer, but it would also necessitate some adjustment on our relay function, all of which is good advice and should be considered as far as the discussion with the client. Okay, one more thing I wanted to touch on before we get adjourned is I want to go back. I'm going to close this because I'm not through with it, but we're not going to complete this analysis. I wanted to touch on ground protection coordination. So let's close this. And again, I'm going to use a sample one line that you have access to. In this case, I'm going to use protection 1.dez. And what I want to show is that in the general, if we look at, so these relays have ground protection set up. And if I go through and look at this, there's a couple things I want to make sure they're set. First of all, when I'm doing relay coordination, I like to see on the name the function that's taking place on the ID. So I relabel them phase and ground. And when we go to settings for the ground, now the tool can't change, say, instantaneous pickup if it's not been enabled during the setup. So that's not the case here. Let's look at the other one. And yeah, so this is actually a ground relay. So let's see if it'll let me change it to ground. Yeah, so this is a phase relay being used as a ground protection. So what that allows me to do now is I come back to, it doesn't allow it. Sorry about that. Oh, let's try that. Yeah, but if I don't have instantaneous setup, it won't necessarily do it itself. Okay, so now to do ground protection or ground coordination, I need to go to my SmartPDC setup. So go to coordination, SmartPDC options. On the general tab, let's say we're just going to do ground only. And we don't have to worry about the 87% derating or damage curve because we have high resistance grounding for the transformer itself. And so this really doesn't apply to the discussion. That's one of the things I wanted you to see. So we're going to pick out this breaker, this relay, this transformer, and then plot the TCC curves. Now to show ground, we need to go into a single line to ground fault, make sure we're looking at just the ground coordination. And what we see, there's one other thing that's it's tricky if you're not showing the full TCC curve because I have things clipped. And so right now I'm not seeing R10. So let's go back to R10, look at the setup. I'm going to undo clipping just so I can see what the curve is. And it shows up now because it was being clipped during that original display. So let's see what SmartPDC does for us in this case. So what we're looking for is to have R10 trip before R7. And these tick marks are the adjustable pickups for R7 and for R10. And so for the currents we're looking to find, if I fault this, I'm looking at a single line to ground fault, and it's going to show me 170 amps. So this shows me a maximum of 200 amps on R10. And we're looking at current in the 2400 volt range. And so this tells me that our 10 will trip before, in fact, the current will never get to the point where this trips on ground current because of that high resistance ground. So this is something I want to play with, but it looks like I'm in pretty good shape as far as R10. And again, I'd want to undo my clipping to make sure things are kosher. And it's not kosher because of what? Ah, so this again, the tool couldn't set up something that I didn't have initiated. All right. And so the clipping prevented the problem. And for 200 amps, I might want to have R10 pick up first. Okay, so that's, again, no other knowledge about the system or the requirements for protection, but the tool allows me to ask questions and go through what if scenarios based upon knowledge that I have from the actual system. Okay, that's what I wanted to cover today. Let's see if we got any questions I can answer. Appreciate everyone joining us today. Thank you for attending today. Look forward to talking with you down the road. Have a good day.